Imagine relying on an AI for a complex medical diagnosis or a critical legal ruling. The system processes the data and outputs an answer with absolute certainty. You act on it, but the answer is entirely wrong. Humans avoid this kind of catastrophic failure through metacognition. It is the ability to monitor our own uncertainty, recognize when our logic is fragile, and pause to self-correct before making a decision. Modern language models operate differently. They are heavily optimized to generate fluent, authoritative text. They are built to provide answers, not to doubt themselves. The danger lies in a specific blind spot. Current systems effectively decouple task performance from self-monitoring. An AI can possess vast amounts of information while remaining completely unaware of its own errors. Standard benchmarks completely miss this flaw. They grade AI the same way we grade a multiple-choice exam, checking if the final output matches the correct answer. They ignore the internal reasoning and self-monitoring process that produced it. Even when researchers try to measure a model's confidence, the tests usually happen in a vacuum. They ask an AI to rate its certainty in total isolation, without testing if the system is genuinely analyzing evidence or simply capitulating to external pressure. A group of researchers created a tool to fix this called MEDLEY-BENCH. It evaluates 35 different AI models using ambiguous problems with no single ground truth answer. It uses genuine intermodel disagreement to probe whether an AI actually knows what it knows. To genuinely trust an AI system, we have to stop testing it in isolation. We need to measure how its logic holds up when challenged. MEDLEY-BENCH uses a 3-step protocol to untangle how models think. Step A isolates the AI to analyze a problem. In Step B, private, it corrects internal contradictions. Finally, Step B, social, applies peer pressure from 8 diverse AI analysts, testing if it revises its original answer. By separating these phases, scientists can track the exact moment an AI decides to change its mind and determine whether that change is driven by independent thought or social peer pressure. This chart tracking AI metacognition reveals a massive dissociation. The orange line showing evaluation rises as models grow, but the blue line representing control stays flat. Tiny models matched massive ones, and newer 31 billion parameter models actually dropped in score. Even elite models show this gap. GPT 5.4, for instance, achieved the benchmark's highest control score, yet it ranked 13th overall because its ability to update its beliefs remained comparatively weak. The researchers call this the articulation illusion. We are training language models to sound incredibly eloquent and persuasive, generating highly polished text that masks a total lack of internal belief regulation. Scaling parameters improves how well a model justifies its answers, but the data suggests it leaves the underlying self-regulation behind. To expose how these models handle social pressure, the researchers introduced a progressive adversarial stage. They kept the specific arguments from the 8 AI analysts exactly the same, but they flipped the fake summary statistics, so the supposed consensus supported the wrong answer. This scatter plot maps the behavioral fallout. The bottom left quadrant reveals argument evaluators, which ignored fake consensus entirely, holding their ground based on evidence. But in the top right are statistics followers. When fake majority numbers flipped, these models abandoned their logic and caved to the crowd. Deploying a statistics follower in a network of multiple agents carries a specific danger. The AI will confidently propagate a popular lie rather than defend an unpopular truth. This heat map reveals the cognitive fingerprints of different AI families. Anthropic's Claude models excel at monitoring, while OpenAI's models lean toward control. But look at the evaluation column. Across all 35 models tested, it is universally red, the absolute weakest ability for every single system. This exposes a systemic knowing-doing gap. An AI successfully recognizes good logic when evaluating external inputs, but it fails completely at turning that scrutiny inward to judge itself. Until AI training pipelines stop rewarding models simply for sounding agreeable and start rewarding proportional, calibrated belief revision, we are building highly persuasive systems entirely devoid of the self-awareness required to trust them.